All right, let's talk about the secret math that's basically running the world around us, from video games to engineering. It all comes down to triangles, and I'm going to show you a completely foolproof workflow to master any of them. Let's dive in.
But to make this real, let's start with a question. Have you ever been deep in a video game and just stopped to wonder, how in the world does that character know exactly where to aim? How does the game figure out that perfect angle in literally a fraction of a second?
Well, it's not magic, it's math. And it's happening so fast you can't even see it. We're talking about a tiny, lightning-fast, 4-step trigonometry loop that's running over and over again, about 60 times every single second, just to make that animation look perfectly smooth.
So let's really dig into the actual problem here. See, the thing is, in programming, and honestly in life, you almost never have all the pieces of the puzzle right from the start. You have to begin with an incomplete picture. So believe it or not, a game engine starts with just two simple numbers. How far over to the target, that's your x difference, and how far up or down, your y difference. And boom, those two lines form the legs of a right triangle. The entire challenge is figuring out everything else from just those two little pieces of info. And that is where our solution comes in, the 4-step master workflow. I want you to think of this as the cheat code for cracking any right triangle problem. It's a simple, reliable recipe that just works every single time. So here's the game plan. Step 1 is always to find that missing side. You know, using our old friend, the Pythagorean theorem. Then, for step 2, and this is super important, you've got to stand at your target angle and give each side a job title: opposite, adjacent, or hypotenuse. Step 3, you just write out SOHCAHTOA. That gives you your 3 main trig functions. And finally, step 4 is the easy part. You just flip those fractions upside down to get the other 3. That's it. That's the whole shebang. Okay, theory is great, but let's see this thing in action. We're going to test drive this recipe on a few problems, starting easy and then ramping it up. All right, first step, we've got a right triangle. Its legs are 3 and 4. We're zeroing in on an angle we'll call theta, and we know it's across from that side with length 3. Our job? Figure out the cosine of theta and the cotangent of theta. So we just follow the recipe. Step 1, find the missing side. We've got the 2 legs, so it's Pythagorean theorem time. 3 squared is 9, 4 squared is 16, add them up, you get 25. What's the square root of 25? It's 5. And just like that, we've got our hypotenuse. Okay, now for what I think is the most crucial step, labeling the roles. From where theta is sitting, the problem told us the side that's 3 units long is opposite. So that means the other leg, the 4, has to be adjacent. And the side we just found, the 5, well, that's always the hypotenuse. It's the long one, right across from the right angle. Now that everything has a label, the rest is a piece of cake. We need cosine, right? SOHCAHTOA tells us CAH, adjacent over hypotenuse. That's just 4 over 5. Then we need cotangent. Well, cotangent is just tangent flipped over. Since tangent is opposite over adjacent, or 3 over 4, we just flip it and we get 4 over 3. Problem solved. Okay, ready for level 2? This one's a little trickier. This time, they're telling us the hypotenuse is 25, and the side adjacent to our angle, which we'll call beta, is 7. We need to find the cosecant of beta. Okay, back to step 1, but watch out for the twist. This time, we already have the hypotenuse, right? The 25, that's our C. So that means to find the missing leg, we're going to have to subtract. So 7 squared is 49, 25 squared is 625. We do 625 minus 49, which gives us 576. And the square root of 576, it's 24. There's our missing side. Perfect. Now we have all 3 sides. We're looking for cosecant. What's that? Oh, yeah, it's just the reciprocal of sine. So first, let's find sine. SOH, opposite over hypotenuse. From beta's point of view, the opposite side is the one we just found, the 24. So sine is 24 over 25. To get cosecant, all we do is flip it, 25 over 24. Easy. All right, time for the boss level. Check this out. We don't even get a triangle this time. All we get is one single clue. The tangent of some angle theta is 2 over 5. And from that one little piece of information, we have to find the exact value of cosine theta. It's like being a math detective. This is where knowing those definitions pays off big time. Tangent, TOA, opposite over adjacent. So if the fraction is 2 over 5, that tells us everything. We can literally just draw a right triangle, pick an angle for theta, and label the side opposite to it 2 and the side adjacent to it 5. We just rebuilt the triangle from scratch. And look at that, we're right back on familiar ground. We just need that third side. Let's run the Pythagorean theorem. 2 squared is 4, 5 squared is 25. Add them. You get 29. Now, 29 isn't a perfect square, and that is totally okay. It just means our hypotenuse is the square root of 29. No big deal.
And now for the final step. We need cosine. That's CAH, adjacent over hypotenuse. So that gives us 5 over the square root of 29. Now there's one little cleanup step. For whatever reason, mathematicians don't love leaving square roots in the bottom of a fraction, so we do a little trick called rationalizing, which tidies it up to our final perfect answer. 5 times the square root of 29 all over 29.
Okay, before we wrap this up, I have to talk about the #1 mistake I see people make. It's so simple, but it will absolutely wreck your whole problem if you're not looking out for it. Let's call it the Pythagoras trap. Just look at the difference here. On the left, you see the mistake. You're given 2 numbers, and your brain goes on autopilot. You just square them and add them up. But wait, the 5 was the hypotenuse. The correct way, on the right, shows the most important move. You always find the hypotenuse first. That's your C. Once you know that, you know if you're supposed to be adding or subtracting. That one little check saves you every time. So let's circle all the way back to where we started, back to that video game character getting ready to aim. That whole 4-step process we just walked through, finding the missing side, labeling the roles, building the fractions, a game engine is doing that for every single object on the screen 60 times a second. It's the silent, invisible engine making that digital world come alive. And that just proves this isn't some abstract thing for your math homework. This is a fundamental building block of the world around us. And it makes you wonder, right? Where else is this little 4-step dance happening? In your phone's GPS? In the bridges you drive over? What other parts of our world are secretly being run by this elegant piece of math? Something to think about.